Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today, we'll be simply explaining the Autoroute Destination feature for routing over an MPLS-TE topology. Understanding networking and telecom doesn't have to be difficult. I simplify these concepts into clear, practical explanations to make learning easier for you, just like I wish it had been for me. If you find this valuable, give the video a like, subscribe, and hit the bell icon so you won't miss out. Over the past few videos, we've been working on the same topology where we have configured MPLS-TE with an OSPF underlay and RSVP-TE. We've created an LSP tunnel from PE1, which is the headend router, to PE2, the tailend router. Our MPLS-TE topology is up and running with a single tunnel already established. We've specifically been looking at routing solutions for MPLS-TE, and we've already looked at static routing through the TE tunnel, as well as the Autoroute Announce feature. In this video, we'll be taking a look at a very specific feature of the Autoroute feature set. It's the Autoroute Destination feature. Let's take a look at what it does. So what does the Autoroute Destination feature do? By enabling it on Tunnel 1, on our PE1 headend router, we are telling the PE1 router to automatically install a static route on the local routing table to the tail end router's IP address via the tunnel interface. The destination IP address in question is actually the IP address on which the TE tunnel terminates. Specifically for this particular tunnel, it's the 2.0.0.2/32 address. The result is quite simple and very specific, but it's quite useful. Let's take a look at how it works in action. Before we configure it, let's take a look at our PE1's routing table. Now, I've removed the Autoroute Announce feature that we had configured in the previous video, and we only see our pure OSPF learned routes in the routing table, as well as some directly connected networks. You can see that the route to the 2.0.0.2 address is actually in our routing table, but it has been learned via OSPF, as expected. There are no static routes in our routing table, right? Now let's configure Autoroute Destination on our Tunnel 1 on PE1. Now I'm including the configuration we had originally applied on our tunnel interface just to remember what we had configured. Here you can see that the tunnel destination is 2.0.0.2, which is indeed our tail end router. So it is this address that will be automatically added to our local routing table. The command to do this is simply this one. Like the Autoroute Announce command, this is the same, except instead of the announce keyword, we're using the destination keyword. Let's see what effect this has on our routing table. You can now see a new static route here to the 2.0.0.2/32 address via the tunnel interface. It's considered directly connected. Not only that, but the OSPF learned route has disappeared, and this makes sense because a static route has a lower administrative distance than an OSPF learned route, so the static route is preferred. Now, I just want to reiterate here that this particular feature doesn't have anything to do with the underlying IGP. It's just an automatic dynamic addition of a static route. Let's take a look at our MPLS forwarding table. Here you can see the specific route is now reachable via the tunnel interface using the local label of 23. And it employs penultimate hop popping, which we can see from the pop label indicator. And it's expected because the next hop is a PE router, and specifically it's PE2. Now someone may ask, why should we use this feature? Is it so much harder to simply create a static route that points to that IP address? Why go to the trouble of using Autoroute Destination instead of simply hardwiring a static route? Well, there are several good reasons to do this. Let's look at the static routing entry as well as the configuration of the tunnel interface. First, the destination command is aware of the tunnel. So if the tunnel goes down for some reason, the static route will be automatically removed. If you configure the static route manually, it will stay there. Secondly, if for whatever reason the tunnel endpoint changes, you don't have to change the static route. Simply by changing the IP address of the tunnel endpoint in the tunnel interface, the static route will automatically change as well. Finally, it's easier to manage such a configuration. If you have just one tunnel, okay, it's not a big deal. But if you have to manage hundreds of MPLS tunnels, putting that command in there will ensure that the static route will always dynamically point to the other end of the tunnel, even if the tunnel parameters change. So that's the use of the Autoroute Destination feature. Now you can use both Autoroute Announce and Autoroute Destination at the same time, thus populating the local routing table of the headend router with both a static route to the other end of the tunnel using Autoroute Destination and a set of OSPF routes that can be reached via the tunnel itself using the Autoroute Announce feature. Remember, for MPLS-TE, the underlying IGP can be either OSPF-TE or ISIS-TE, so either routing protocol will work with these Autoroute features. For now, I hope you found this video useful, and if you have, please click that thumbs up button. If you have any questions or feedback, please feel free to leave a comment. I'm always happy to read them and to respond. And please subscribe to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.